Good morning to all of you. Good morning, everyone. I hope my voice is clear to you and PPT is shown in screen. Today's paper is electric drives and control. So first of all, we have to know what is an electric drive. In industry or in domestic appliance, in many times we have to control the motion of several doors or fan like that. Then if we say that the system employed for motion control are called drives. That means whenever we apply a system to control some motion, that system is called drives. The motion may be diesel or petrol engine, may be of gas turbine or steam engine, like that. If we apply the electric motor or drives employed for electric motor, then we call that type drives is electric drives. That means a system which is control the motion of electric motor or speed of the electric motor is called electric drives. Can you get that? Is it too clear to you what is an electric drive? Okay. Okay. Hold, hold a minute. I have to join some people. Next, this is a block diagram of commonly electric drives, or you may say that a common block diagram of drive system. Here we say that because we use motor, so we say that this is the block diagram of electric drives. What are the blocks? The first block is source, then the power modulator, then motor and the load. And there is a feedback system which is consist of sensing unit and control unit. Can you tell me whether it is a open loop system or closed loop system? Why you say that? Good. Though there is a feedback path, that means it is a closed loop system. Okay, just hold on. Okay, now the first block is source. So, what kind of source are available here? Can you say that? Which type? If it is a electric source, then which kind of electric source are available? Either it may be AC or DC. That means there are two types of electrical source are available. One is DC type, another is AC type. Next, we go to the next module, the power modulator. What is power modulator? Power modulator is such things that it control or modulate the source signal to the motor so that the motor can easily accept that signal, or you can say that motor can easily access that signal. And also the function of power modulator, maybe it's converter. If suppose we use a DC motor and the types of source is AC, then what is the function of power modulator? We are using a DC motor and the source type is AC. Then what should be the function of power modulator? Convert AC into DC. That means the function of that time of power modulator is rectifier type. And if the source is DC type and the motor is induction motor, then what is the function of that time of power modulator? What is the function of that time? The source type is DC and the motor is AC. Inverter. Good. Then we go to the next block, the motor block. How many types of motor are available? Tell me, how many types of motor are available? DC motor, AC motor. You know that? Now tell me, how many types of DC motor are there? Series, shunt, and compound. There are three types of DC motor available. Mainly we used this type of, and some special DC motor also available. Like that. The special type is servo motor, stepper motor, BLDC motor, permanent magnet DC motor. And how many types of compound DC motor are available? Like series compound, shunt compound. No, no. Can anyone have the right answer? How many types of compound motor are available? Cumulative type and differential type. Good. There are two types of compound motor are available: cumulative type and differential type. This is based on the nature of the field of two field coil, and based on the position of the field coil, how many types of compound motor are available? One is long shunt and another is Based on the position of the field coil, there are two types of compound motor. One is called long shunt and another is called short shunt. Good. And what about AC motor? How many types of AC motor are available? Good, good. Synchronous and asynchronous. Which motor is called synchronous motor and which motor is called asynchronous motor? Or why a motor is called synchronous or asynchronous? Good, good. That means the motor which has a rotating at synchronous speed is called synchronous motor. The motor whose rotor is not rotating with synchronous speed is called asynchronous motor. The asynchronous motor is also called induction motor. अच्छा, so go to the next slide. That means if we apply a system or a drive in electric or to control the speed of electric motor, then this type drives is called electric drives. What are the advantages of electric drives? Why we prefer electric drives? Why we prefer electric drives? Why we prefer electric energy? In the previous, they can easily control. Okay. Then next, suppose I have a diesel engine and I have a motor. Which one is fast controllable? Tell me, which one is fast controllable? Between motor, between a motor, between a motor and a diesel engine, the motor is fast controllable. And if we suppose I have to start a motor and a diesel engine, which one is start fast or taking time less time to start? Diesel engine or motor? Motor. That means they can that means the motor can start it instantly. Okay. And now tell me what about pollution? Which one is more polluted? The environment. Diesel engine or an electric motor? Diesel. So we prefer electric motor because the electric motors are not polluted the environment. Now we go to the first point of advantage of electric drives. They have flexible control characteristics. What is the meaning of that? Can anyone explain? According to our requirement. And uh, suppose the steady state and dynamic characteristics of electric drives can easily controllable. That means the electric braking, the speed control, starting, they can easily controllable. The next point is they are available in wide range of torque and speed and power. That means there are several motors are available by which we can control that wide range of torque, speed and power. Suppose I have a diesel engine and I have a electric motor. The rated speed of that two machine are 1500. Suppose we have an we have a diesel engine and electric motor. The rated speed of that two machines is 1500. Can I run the diesel engine at the speed of 2000? Can I run? No. Can I run the motor at 2000 rpm? Yes or no? Yes or no? I have a motor with rated speed of 1500, but I want to rotate that motor and 2000 rpm. Can I run that motor? Yes, we can, because we can run any motor up to 150% easily, because there is provided a safety of 50% about the 50% above of rated speed. So we can say that the availability of speed is wide range, and also the motor have the speed variation. Like if you use a universal motor, then the speed of that motor may be 5000, 6000, like that, and it can be easily controlled between 0 to 6000 rpm. And the efficiency of electric motor have high. That means when we use electric motor, the efficiency is near about 70%. The next point is they are adaptable to almost any operating condition. That means suppose there is an inflammable environment. Can I use an diesel engine there? Can I? I have a inflammable environment. Can I use a diesel engine? The answer is no. Can I use there a induction motor? Can I use? Why? Good answer is good. You are absolutely right. But why we can use at that time an induction motor? But we cannot use diesel engine, but we can use an induction motor. Why? Doesn't produce any sparking. Your answer should be induction motor. It's not producing any sparking. That's why we can use induction motor. So that's why we are saying that they are adaptable to almost any operating condition. That means based on any environment, we can choose any kind of electric motor or sorry, মানে based on environment, we choose suitable electric motor. And do you know four quadrant operation of electric motor? Have you any idea about the four quadrant operation of electric motor? Have you any idea? Okay, let's leave now. We can explain it later. And the last one, they can be started instantly. That point is discussed, already discussed. Then parts of electric drives. What are the parts of electric drives? We have already seen in block diagram. Electric motors, power modulator, source control unit. These are the parts of electric drives. Suppose I have a DC motor and the source type is AC. Then we can use a rectifier. The power modulator at that time uses a rectifier. There are two types of rectifier available. One is called uncontrolled rectifier, another is called full control rectifier or control rectifier. In control rectifier, there are two types. One is called half control, another is called full control. Do you know what is uncontrolled or control rectifier? Good, good. In case of uncontrolled, we use diode, and in case of control, we use thyristor. By using thyristor, we can vary the output. Suppose I have a fixed AC voltage and the output should be variable DC, but there is available only diode. There is no available of thyristor. Then is there any procedure to fulfill our purpose? We have a fixed AC voltage. We have to change it variable DC voltage, but we have available only diode. There is no availability of thyristor in previous time. That means in the previous time of 1980 or 1970, there is no available of thyristor commercially in market. At that time, what we use or what should be the procedure to fulfill from fixed AC to variable AC? No, the source type is AC, and the output type is variable DC. First we use diode. That means the AC type voltage is converted into fixed DC. Then no, I am saying that at the time of 1950, suppose you are in 1950, there is no available of any power electronics device. That means there is no available thyristor or power MOSFET, power, that means IGBT. First, change the variable. First change the fixed AC to variable AC, by which device or by which machine we can change fixed AC to fixed AC to variable AC. That is transformer. So first use a transformer, then the fixed AC voltage is converted into variable AC voltage. Then use the rectifier. Then use a rectifier. Then a fixed AC voltage is converted into variable AC voltage. Okay, wait a moment. There is someone waiting. So this class is going on up to 10:40. So when the meeting is ended, then please rejoin me because this class is going up to 10:40. Suppose we have available of fixed AC and we try to change it into variable DC. Now we are talking about 2021. Then we can use chopper, and we can suppose we can use first a diode rectifier and then we can use a chopper. Then the fixed AC voltage is converted into variable DC. Suppose and we also use fully controlled rectifier. So like that we can change the voltage from one type to another type. So, what are the factor based on we choose an electric diode? What are the factors based on which we choose an electric diode? The steady state operation requirement. The first point is steady state operation requirement. That means the load have some speed control. That means there is some requirement of nature of speed control, speed regulation, speed range, duty cycle, like that. So we have to first study the nature of our load requirement. Then we choose the corresponding electric drives. Then the transient operation requirement. That means a motor, if we use uh, a motor, then the value of acceleration, deceleration, starting, braking, reversing, like that, all the transient operation requirement also be fulfilled. And the next point is requirements related to the source. That means what kind of electric source is available. Based on that, we have to choose electrical drives. Then the next point is capital cost, running cost, maintenance need. That means suppose we have to choose such a that electric drives, the initial cost or running cost is not too much high. So we have to maintain all this. And the next point is and weight restriction. If there is some space or weight restriction, then we have to consider that point also. The environment and location. I have said that previously, if there is a inflammable environment, then you have to use a cell type induction motor, because if you use that environment a DC type motor, then the sparking is happen in bus and commutator. So we cannot choose that kind of motor there. So we have to choose there a self induction motor. And in case of submersible, we have to also choose a self induction motor. So based on the environment and location, we have to choose electrical drive system. The next part is reliability. The next part is reliability. That means suppose we have used a motor for submersible and we have to maintenance in a month, or we have to repair after 6 months. Is it desirable or not? Is it desirable? Suppose we have to choose an electric drive system and electric motor system for submersible type. We should choose such a motor that it run for.